In this video, I'm going to start working on a 2D engine or a library of functions that's going to make it easy to write a game. And now that we have some fluency with Pico 8, we can start making this library of code, and then we can reuse it anytime we want to make a game. And that's in fact what I do. I have this library of stuff, and then anytime I want to make a game, I use it. And I don't have to reinvent the wheel every time. So then now you're going to be able to do the same. So what I've got here is an empty Pico 8 project called 2D Test. And this is where I'm going to test out my 2D engine here. And what I'm going to do is I'm going to go make a file called 2D Engine. And then I'm going to include it in here. Include 2D Engine. We'll call it that, .lua. And I haven't made that file yet. But we'll go do that. And then let's give ourselves our 3 functions. Oh, let's also include colors. You know, probably want that too. Colors.lua, just in case. And then let's give ourselves our init, update, and draw functions. All right, so we're just making a test harness for testing out our library. And then I'll go up here and I'll set the language to Lua. There we go. All right, that looks a lot prettier. Okay, neat. Now, let's go, let me make myself a file here, new, and I'm going to save it as, and that should go into my carts folder. I'm going to call it 2dengine.lua, and I'll overwrite it. Okay, so in this file now, 2dengine.lua, let's also make sure that I guess it is set to Lua. Okay, library of code for making 2D games. All right, maybe I'll put my name in here. Evan Wright, 2021. Awesome. Okay, so what sort of stuff do we want to be able to do? Well, we want to be able to create objects, and we want to be able to have objects move around the screen, and we want to be able to draw objects, and then possibly delete objects, and also do collision detection. So that's the kind of stuff that we're going to start doing. And we'll build out this library incrementally, you know, a few functions at a time. So let me, let's start by thinking about what does an object need? Like an object needs, like, you know, a coordinate on the screen, maybe a speed, a direction, and maybe a sprite. Those would all be properties of an object. And maybe it needs a draw function, and maybe it needs you know, a function for moving it. So let's go add that stuff and sort of see how it goes. So I'm going to make a new function here, and I'll call it, like, you know, maybe make object or new object. I'll call it new object here. Okay, now what parameters do we want our object to have? And we've got some, you know, I'd say let's start basic, and then we can add more. We can add complexity later. But let's just assume that every object's going to have an x and a y coordinate on the screen, and maybe it's got a sprite, and maybe it has a speed, and maybe it has a direction, and let's keep it at that. We'll kind of keep it simple here. So we'll say these are the things that every object is going to have. Every object is going to have an x and a y, a sprite, a speed, and a direction. And we can add more stuff later because, remember, Lua allows us to add properties to objects on the fly. So what I'm going to do here is I'm going to make a local variable. And this variable is going to be a table, right? This open, close, curly braces, we're making a new object. Make a new object. And now we can assign properties to that object. So, and we do that using the dot operator, just like we did in Lantern, like we've been doing in Lua too. So let's say O's x coordinate is now equal to x. Which x is that? That's this. We're saying set this object's x coordinate to that. Set this object's y coordinate to that. Set this object's sprite property to whatever that happens to be. Set the object's speed property to whatever is being passed in as the parameter here. And then let's also say, let's set this object's direction to be direction. There we go. Okay. Now, let's make this a little more interesting. So these are the properties on that object. I want to add another one here. I want to make one called destroy, and I'm going to set that to false. So we may not use this. This will be used if we need to remove stuff from a list. You can run into trouble if you try to delete things out of a list while you're iterating through the list. So maybe if we're going to destroy objects, we don't want to delete them right away. We're just going to set their destroy property to true, and then later we'll say, you know what? Let's go through our list of objects, and we're going to delete anything that may not that we don't need anymore. Anything we're supposed to destroy, we'll go clean it up out of the list. And then let's also add, let's add a visible property, and we'll set that to true. And maybe when we draw the thing, maybe we want to use that. So we can notice we can just kind of add whatever properties we want to this object. And then finally, once we're done with our object, we want to return it to the caller. We want to say, we want to give this object back to the person who's trying to make a new object. Because we're saying, hey, go make me a new object with these parameters and give it back to me. Now that you've made it, I need it back. All right. So there's a function for making an object. And I'm sure that will work. Now let's also let's think about how we're going to do this. Now that we've got this object, let's add another function, and I'm going to add it up here, and you'll see why in a second. I'm going to add a function called move object. And what is this move object function going to do? Well, it's going to, and let me put it here, like create a new, creates and returns a new object. And then this is going to be moves an object based on its speed and direction. All right. So this function that moves, called move object, what does it need as a parameter? Well, it needs the object to move, right? We're going to say, hey, function, I'm going to give you an object, move it. That object will have a speed and a direction, and I want you to move it. I want you to change its x and y coordinate based on its speed and direction. So to do that, we need some sines and cosines. We're going to have to figure out the cosine of the x coordinate will change by the cosine of the direction times the speed, and the y coordinate will change by the sine of this object's direction times its speed. So, and if you're weak on sines and cosines, don't worry about it. I'm going to type it out for you here. So the object's new x coordinate is going to be, it's wherever it is, its current x coordinate, plus the cosine of its direction, right? And here's its direction right here. Remember, we gave objects a direction? All right, now, there's a trick. When you take sines and cosines in Pico 8, we don't use radians, we use fractions of a circle. So we have to divide our angle by 360 to convert that angle to a fraction of a circle. And then remember, sines and cosines are based on the unit circle, which has a radius of 1. So we don't want to move at a speed of 1. We want to move proportional to our speed, because this object has a speed that may not be 1. So that should do it for us. And then our y is going to change in a similar fashion, except that it will change by the sine. Now, we'll see how these angles work out. I have my own kind of way of imagining angles, but we'll test this out. All right, so there's a move object function. All right. Okay. So now that, why did I put this up here though? Right? Why did I do that? Well, it's because, let's go down here. And we're going to say that this object, we're going to give this object a function called move. And no, we're not. No, we're not. No, we're good. We'll just leave it like that. In fact, we don't even really need it up there. Let's just put it down here. I'm kind of getting a little bit, in my head I want to do things, but, all right. I'm trying to keep it simple. All right, so now what we have here is a way of creating objects and a way of moving those objects. Now what we also should add is a function for drawing those objects. Now an object could have, maybe we want to draw it different ways. Maybe we want to give an object a draw function. Let's just build one in here. Let's make a function called draw object, and let's make an easy one here. Now this is going to take as a parameter the object to draw. Draws the supplied object. Draws the supplied object centered at its x and y. All right. So how do we do that? Okay, so then we just use the SPR function. Oh, but let's also check to see if it's visible, right? We've got this thing called visible here. Let's use that. We'll say if this object, now, so everything I do here is going to be prefaced by O dot, right? I want to, because this draw function applies to the object that I'm giving it, right? This thing is like f of x, right? Here's x, go do something to it. That's what these functions do. Hey, draw object function. Go draw me this object. What object? I don't know. The one I'm giving you, the one called O. So let's say if O is visible. And now I could write this out as, I could write it out like that. That would work. Now it turns out I don't really need the equals true, because if this is true, then the whole thing is true anyway. But I'll just leave it there just for clarity. So if O is visible, then let's use the SPR function, which draws sprites. Okay, so now what sprite do we want to draw? We want to draw O's sprite. O's sprite, O.S-P-R-I-T, there we go. And where do we want to draw it? We want to draw it at O's x coordinate and O's y coordinate. Okay, however, well, okay, so it's up to you. Well, maybe we want our sprites centered. I guess I can leave this up to you. But what I'm going to do is I'm going to say -4 and -4. Now, I guess you don't have to do that. But the sprites are 8 by 8, so I guess it's up to you whether you want your sprites centered or not. I guess in my mind, I kind of want them centered around their coordinate. But that's that's your call. So now that I have this draw function here, let's go give this thing a draw function. Draw equals draw object. So this might be a bit of a mind bender. We can assign properties to objects, but we can also assign functions to objects. So this is not an object-oriented framework like Java or C#, but we can kind of fake that. We can say, hey, you know what? Hey, object, you have a draw function, and I want it to point to this draw object function up here. So, phone problems. So now we could make an object, and we could have a different drawing function, and say, hey object, your draw function is now something else. That would be like polymorphism or something. We could have a whole bunch of objects, and they all have a draw function, but it's a different function. But this is going to be enough to get us going. So this says if the object is visible, draw its sprite centered at its coordinate. Okay, so this ought to be enough to get us going, at least for this first exercise. Hopefully all the code here is right. So, but now we have the means of creating a new object, moving an object, and drawing an object. Also, why did I have to declare this thing up here? Because this function needed to exist before I use it down here. Otherwise, if the syntax checker finds this thing before it sees the before it actually sees the function, it'll just use nil, and you won't get the result that you think. Okay, so now let's go try this out. Let's go back to 2D test here. And I should be, okay, so first of all, let's just load this thing. Okay, that's cool. All right. Hey, it didn't crash. Fantastic. All right. Let me include my alarms too. Include alarms.lua. So right now, this is actually a pretty cool, I mean, this is good right here. This is a really good template for a project. What I'm going to do here is make a list, and I don't know, what do I call it? I'll call it objects or something, and I'll set it equal to a new list. Now, in your game, when you make a game, what I highly recommend doing is keeping different things in different lists. So if you have a list of enemies, or if you have enemies that fire shots, and there's obstacles in your game, I would have a list of obstacles, a list of shots, and I would have a list of enemies, and maybe keep the player as a separate object. I say don't put everything in one list. I would say have different lists for different types of objects. That will make your life a whole lot easier. Then it'll make it easy to check to see, okay, well, did the shots hit any enemies? All right, well, I have to use a loop to go through all the shots and compare every shot to every enemy to check for a collision. All right, so there's my list of objects. And now let me just populate it with something here. For I equals 0 to 360, maybe going up by 10 every time, do end, and then what I'm going to do is I'm going to use my library, and I'm going to say equals, is it new object? New object. And where am I going to make this thing? Where am I going to make my object? 63, 63. Let's go back to our 2D engine here. So when we make an object, we make it at x, y, then we supply a sprite, a speed, and a direction. So x, y, a sprite. I'll use sprite 1. I haven't made sprite 1 yet. And then I need speed. I don't know. Let's give it 1, 2. I don't know, 5, 3, whatever. And a direction. And I'm going to make the direction I here, and you'll see why in a second. So you can see what I'm doing here is I'm creating a whole bunch of objects at 63, 63 with sprite 1. They all have the same speed, but their angle's all different. And now once I've made this thing, let me put it in objects. Add objects. Oh. So I've made, oh, is that a 0? Oh God, that's awful. All right. I'm going to make an object called O, and then I'm going to make a new object, and then I'm going to put it in my list. All right. Awesome. Let's just see if that works. Okay, cool. Did not crash. Great. So do you see what I'm doing here? I'm writing a little bit of code, testing a little bit of code. Write a little bit, test a little bit. Write a little bit, test a little bit. Okay, now let's see if we can get these things drawing. Now this is where we've got this list here. This is where we want to use that for S in all ships thing that we saw on the cheat sheet. I'm going to call it like for O in all objects do end. There we go. That's our repetition structure for crawling through a list of objects and pulling out each one at a time, and we're going to refer to it as O, and then we can do something to it. So what are we going to do? Let's call O's draw function. It's going to be a little weird. O, our object O has a draw function. However, if you go back here, you'll notice the draw function requires an object to draw. This is not a true object-oriented framework like C# and Java. So we have to supply the object to draw. We're saying call O's draw function and give it O. So this is what it's going to look like. Call O's draw function and give it O. That's a little bit of a hack. There is a shorthand way of doing that. It's the colon. These two statements here are exactly the same. This is a little cleaner, but it's kind of, I don't know. Let's just try to keep it simple. So that's going to draw all of our objects. All right, and then I think we said we were going to use sprite 1. So let's go back to, let's reload that. And let me go to my sprites. And for sprite 1, let me give myself like, oh, I could have just used that thing, but let me give myself like, you know, a blue. Oh, God, I always, the art. I hate art. Art. Drives me crazy. 1, 2, 3, 4. All right, we'll call that our sprite. There's sprite 1. All right, so now if I run this, I should see a whole bunch of, oh, okay, that looks promising. Let's clear the screen in our draw function here. There we go, clear the screen. So now what I'm going to do, let's run that again. Did not reload unsaved changes. Okay, save. All right. I probably lost my CLS there. CLS. Oops. Boom. Okay. So there's all of our objects at the center of the screen. So what we also want to do is update them now. So let's take this exact thing of code here, and I'm going to put it in the update function. What I'm going to do, I'm just going to paste that in there. I'm going to do, let's see. Let's look at our 2D engine. We have a function here for moving an object. So we have to give it an object to move, right? That first parameter, that's the object to move. Well, let's try it. Move. Oh. Now this is, we could have done the same thing where we give every object a move function, but movement's kind of the same for every object, so I'm just going to kind of keep it simple like that. And then let's run this and see what it does. On attempt to call a globe, oh, because it's not move, it's move object. There we go. Now let's go run it. Oh, cool. All right, so it exploded. All right, now, so you see what we did there. And then let me just change this to, you know, let's say 0 to 60 or something. Let's just, there, that's kind of cool. So what I'm doing here, let's say 0 to 180. Well, that was not what I expected. Oh, the angles are going counterclockwise. Yeah, just like the unit circle. That actually kind of makes sense. So 0 is to the right. And then if I do 270 here, I bet we'll get the bottom left quadrant will be empty. Oh, the bottom right quadrant was empty there. Oh, no, that was correct. That was correct. Yep. That was correct. All right, so there you go. What I did was I just spun out you know, a whole bunch of objects using a list. Now, just for fun here, you know, let me use my alarm library. I'm going to make something called alarm, you know, equals make alarm or something. I forget what I did. Alarm, and then I call a function in a certain number of ticks or something. So let's say 90 ticks. I want to call my, you know, reset function, and then it means I need a function called reset. Function reset, and you know, I kind of forget. Is it the ticks and then the function? We'll find out here. And then also, this is something I do all the time. The first thing you want to do in your update function is called update alarms. You want to run your alarms. And then what else do I want to do? Okay, and then in my reset function, what I'm going to do is I'm going to put all the objects back at the center. For every object here, I'm going to set its x to 63 and its y to 63. I'm going to put it back at the center of the screen, and then I'm going to restart my alarm. Restart alarm, and I want to start my alarm in, I don't know, another 90 ticks. Let me just double check that. All right, oops, wait, wrong code. Sure, why not? Wrong code, there we go. All right, so yeah, that's all good, So when our reset function calls, I'm gonna loop through all my objects, put them back at the origin. Oh, and I don't need the semicolons. I'm sorry, I'm just used to programming in other languages that require that. And then I'm gonna restart my alarm. And so it goes again in another 3 seconds. And now if I run this, 1, 2, 3, 1, 2, 3. So there we go. So now it's just going to sit there. Every time the timer ticks, it puts everything back at the origin. You know, if I wanted everything to run faster, I can just change this timeout value here. There we go. That's pretty cool. All right, so that's very, very useful, what we've got there. Now we've got this 2D engine here where we have the ability to draw an object, where we have the ability to create an object, and we have the ability to move objects. All right, so let's call that a day, and then in the next video we'll add some more stuff to our library that's going to be useful for games.